Hello students, so here are the suggested solutions for your assignment 1A. The first question, if n is a whole number such that n times n plus 42 is a prime number, find the prime number. Explain your answer. So what we can do here, right, since we are supposed to explain, we need to actually first let everyone know what a prime number is. So since the product of n and n plus 42 is a prime number, we can actually let everyone know that the factors are n and n plus 42, as you can see. So we write down since n times n plus 42 is a prime number, the factors are n and n plus 42. Now that we have established that fact, we bring in the property of the prime number and says that, well, in that case, n has to be equals to 1, right? Because we know that for a prime number, it has exactly two factors and one of the factor is actually 1. So since n is a smaller number compared to n plus 42, naturally it has to be the one that is equals to 1. So the prime number that we're looking at now, the product will end up being 1 times 1 plus 42, which gives us 43. So since this is an explaining question, we have to use some keywords there to help us, right? For example, words such as since, because, therefore, etc. You do not just write down your calculations. It is actually insufficient. To explain something, we must show the evidence, we must show the argument, and then we must have a conclusion, right? Okay, so the next question. Now, the next question I ask you to try are just a series of prime factorization. So here's the first question. Find the prime factorization of each of the following numbers, leaving your answer in index notation. So for 8,624, this is what we do. Okay, we roll down, dividing the number by each prime factors. As we go down, we will find that it's actually 2 to the power of 4 times 7 squared times 11. Now, make sure when we write it down, okay, we do so from the smallest prime factors to the largest prime factors. Mathematically, it's not wrong to rearrange them, but by convention and good habit, we should actually arrange them in order. Okay, so that's what we get for the first one. For the second one, 6,804, when we break it down, we get 2 to the power of 2 times 3 to the power of 5 times 7. Next one, similarly, the same process, we get 3 to the power of 4 times 17 times 19. Right? And finally, for part D, after we break it down, we get 2 to the power of 5 times 5 to the power of 3 times 7 squared. Now let's move on to the open-ended question. So here's the first open-ended question that I advise you to try. We have Ali, who wants to use 210 1 centimeter cubes to make a cuboid such that each of the sides is longer than 1 cm. There are 6 possible cuboids that he can make. Find the dimensions of any 3 of them. So when we perform our factorization, we realize that 210 can be equals to 2 times 3 times 5 times 7. Now, since it is a cuboid, we want to have 3 factors, right? So from these 4 factors, we can actually get 6 possible combinations. So they are listed there on your screen, as you can see. Now, since the answer that the question require you to only provide 3 of them, we just select any 3 of the 6 that is possible and to list them down. So you write down in this manner. Now, please, because it is a word problem with a context and a dimension, we should answer to the question. So in this case, okay, to present it properly, we should say something like 3 centimeters by 5 centimeter by 14 centimeter. We shouldn't just leave it as 3 times 5 times 14 without any units, without any proper dimension. Dimension, we actually usually express it as a certain length by a certain length by a certain length. So do present it properly and answer to the question. And here's the next question that you were told to try. So Devi uses 504 1 centimeter cubes to make a cuboid. the perimeter of the top of the cuboid is 20 cm, each side of the cuboid is longer than 2 cm, right? Find a possible height. So since the perimeter of the top is 20, there are a few different combinations that will allow us to get 20, right? So when we break down 504, we get 2 cubed times 3 squared times 7. Now, since the perimeter is 20 cm, the two combinations that we can obtain from these sets of prime factors are actually 3 by 7. You know, if I get a 3 by 7 rectangle, I have a perimeter of 20, or I get a 4 by 6, right? If I got a 4 by 6 rectangle as the top, I also have a perimeter of 20, which means, right, there are actually two possible combinations. Okay, so the two combinations are either 3 by 7 by 24 or 4 by 6 by 21. So when we look at it this way, we will realize that the possible height is actually 21 centimeter or 24 centimeter. There should be two possible solutions over here. All right, so I hope you have a successful practice and got all the questions correct. If not, do complete your corrections and to reflect on the corrections and learn from them. Have a nice day.